Welcome to another video session on plane surfaces immersed or in contact with water. So in the theory part we had discussed about the total pressure, that is the pressure force acting on a planar surface which are in contact with a liquid, and also the location or the point through which this total pressure is acting we have designated as P, and that point is called center of pressure. So we had derived equations for total pressure as well as center of pressure for three cases. The first case was horizontal planar surface immersed in fluid or liquid, vertical surface immersed in liquid, and inclined surface which are inclined at an angle theta with respect to the free surface of water. So we had derived equations for total pressure as well as center of pressure for these three cases, and now we are going to apply these equations for doing some numerical problems belonging to this section. So the first problem is related to a rectangular planar surface. So remember that in a liquid it may be either fully submerged or maybe partially submerged. In both the cases we can apply the same formula for the estimation of total pressure. So the first problem is like this: a rectangular plane surface 2 meter wide and 3 meter deep lies in water in such a way that its plane makes an angle of 30 degrees with the free surface of the water. That is, it is a rectangular plane which is inclined at an angle of 30 degrees with the plane surface. So theta is 30. Determine the total pressure and position of center of pressure. That means position of center of pressure from the free surface of water when the upper edge is 1.5 meters below the free water surface. Okay, so how will you approach this problem? It's a very simple problem. The dimensions are given 2 meters into 3 meters, so the area will be 6 meters square, and theta is given as 30 degrees. And so first of all we have to sketch this arrangement. So this is the arrangement. This is a rectangular plate, 3 meter depth and 2 meter dimension in the other axis. So the area will be 3 into 2, that is 6 meters square. And the upper edge, so this is the upper edge which is at a distance of this is the upper edge. It is at a distance of 1.5 meter from the free surface. So this dotted line represents the free surface of water, and this angle is theta. Okay, then G, as you know, it is a center of gravity which is at a distance of vertical distance is h bar. That was the terminology we used, h bar from the free surface. So CD represents h bar, and P is the center of pressure that we have to estimate. So as we know, the designation used is H star as the vertical distance of the center of pressure from the free surface. So H star as per this figure is Fg. Okay, so we have used proper terminologies: H star, H bar, theta, etc. Then some dimensions are marked. Given problem, in the problem it is given, it is 1.5 meter, that is AB. The top surface of the top point of the lamina is at a distance of 1.5 meter from the free surface. So AB is 1.5, CD is h bar. So if you drop a horizontal line from B, it will reach here at E. So CE equal to AB. So as per this arrangement, CE equal to AB equal to 1.5. Okay, then center of pressure H star, it is Fg. Okay, then what about the center of gravity? As we know, center of gravity is a geometric center of the surface. So this is 1.5 meters marked because the total length is 3 meters. So with this information we will try to do this problem. So the given data, as I have already told, it is area is 6 meters square. And before that, what are the variables which we require for estimation of center of pressure? We need to have density of water, area, G, and h bar. So these are the parameters which we require for the estimation of total pressure. So the angle made by the free surface, made by the plate with the free surface, it is theta equal to 30 degrees. Then what is the equation for total pressure? We have discussed, we have derived the equation as P equal to rho G A h bar. Okay, so h bar is the distance of the center of gravity, vertical distance of the center of gravity of the plate from the free liquid level. So rho, it is water, we know it is 10 raised to 3 kilogram per meter cube. G, that is acceleration due to gravity. A, that is 6 meters square in this case. And what is h bar? So as per this figure, h bar equal to CE plus ED, that is, this is CE plus ED. What is CE? So it is 1.5 meters. How to get ED? So here you have a right angled triangle. Look at this figure, BED. So this is a right angled triangle, BED. So from this right angled triangle, what is ED? ED is BD sine 30. Okay, BD sine 30, because sine 30 equal to opposite side divided by hypotenuse, or sine 30 equal to ED by BD. So you will get ED as BD sine 30. So 1.5 plus 1.5 sine 30 will give you 2.25 meters as h bar. So if you are substituting the value of h bar, you will get the total pressure as rho GA h bar equal to 132.435 kilopascal, or 132.435 pascal, or Newton per meter square. So that is the total pressure acting on this rectangular plane surface, which is immersed in a fluid. The fluid is water. And now we have to estimate the center of pressure. So how to estimate the center of pressure? So this is the equation for the center of pressure. What is the equation? H star, you read it as H star equal to h bar plus Ig sine square theta divided by AH bar. So you should learn this equation. Okay, then only you can do this problem. We had derived this equation in the previous video session. So h bar plus Ig sine square theta by AH bar. So what is the unknown parameter here? H bar is known. We have found out h bar. We know that it is a geometric center. Theta is known, A is known, h bar is known. The only unknown is Ig. What is Ig? Ig, we know it is the moment of inertia of the planar surface about the center of gravity, or axis passing through the center of gravity. So it is a rectangular plate. So for rectangular plate, rectangular surface, we know that Ig, moment of inertia through the central axis, is B dq by 12. Okay, you have two dimensions, one is B, other one is D. So B dq by 12, 2 into 3q by 12 will give you 4.5 meter raised to 4 as Ig. Okay, moment of inertia. So if you substitute moment of inertia in this equation, you will get h star as 2.34 meters. Okay, 2.34 meters. So what was h bar? What was the value of h bar? H bar, let us see what is h bar. H bar was 2.25 meters and h star is 2.34 meters. That is, you can find out, or you can see the relative position of center of gravity and center of pressure from this numerical values of h bar and h star. H star is below h bar. Okay, so this is how we do a numerical problem in this section, that is a plane surface immersed in a liquid. Only thing you want to know is that you should know the equations for center of pressure as well as total pressure and the orientation of the plate. We will do another problem. Okay, determine the total pressure and center of pressure. Again, a similar problem of an isosceles triangular plate. Geometry is different. It is a planar surface which is an isosceles triangular plate of base 5 meters. Okay, altitude or height 5 meters. When the plate is immersed vertically in an oil of specific gravity 0.8. Here it is not water, the fluid is oil. The base of the plate is 1 meter below the free surface of oil. Okay, the base of the plate is 1 meter below the free surface of oil. So we have to sketch this arrangement. So this is the free surface of the liquid. So it is an isosceles triangular plate. Okay, so what about the position, orientation? It is given the base of the plate is 1 meter below the free surface of liquid. So we draw like this. The base is close to the free surface, which is at a distance 1 meter, and the apex down. Okay, apex is down and the base is on the upper part, which is at a distance of, as given in the problem, it is 1 meter below the free surface of oil. Free surface of oil, and the specific gravity of oil, it is given as 0.8. Then what is h? H is the height or altitude of this isosceles triangle, and the base length is also given as 5 meters. Since it is isosceles triangle, the other two sides other than the base are having same dimension. Okay, so let us read the question once again. Determine the total pressure and center of pressure, that is P and H star of an isosceles triangle, base 5 meter, altitude 5 meter. So if base and altitude length are given, you can find out the area of this isosceles triangle. So how to get the area of the triangle? It is half BH, half into base length into altitude length. It is immersed vertically, so that is very important. Here it is, plate is not inclined with the plane surface, but it is immersed vertically. Okay, so the problem has been worked out here. So what is the total pressure P for a vertical plate immersed in a liquid? The formula had been derived. It is rho GA x bar. Okay, it is not inclined, but it is vertical. So theta does not come into picture. The angle theta does not come into picture. So rho, it is 0.8 into 10 raised to 3. Since specific gravity of oil is 0.8. G, area. What is the area of this triangle? How to get the area of this triangle? We know that area of the triangle is half BH. So half into 5 into 5 will give you 12.5 meter square. Okay. Then what is x bar? So x bar is the position of the center of gravity of this isosceles plate from the free surface. Okay. So you have to locate the center of gravity. So where is the location of the center of gravity? Maybe somewhere around here. So if it is a triangle, the center of gravity is 2/3 of the altitude from the base. Okay, 2/3, that you know, 2/3 of the altitude from the base, or 1/3 from the, it is 1/3 from the base or 2/3 from the apex. Okay, 1/3 of the altitude from the base. So it is given. So x bar will be the distance from the free surface of water. So 1 meter plus, so this distance is 1 meter plus 1/3 of the altitude, that is 1/3 of the 5. So 1 plus 5/3, that will give you 8/3 meters. So if you substitute 8/3 here, you will get P as rho GA into x bar, that will give you 261 kilopascal. Okay, so you should know how to get or how to locate the center of gravity of a triangle. That is always 2/3 of the height from the base, or 2/3 of the height from the apex, or 1/3 of the height from the base. So that is basic mathematics. So once we know that, you can do this problem and you find out P as 261 kilopascal. And now the next part, it is center of pressure H bar in this case. So what is the formula? You should study this formula. H bar equal to x bar plus Ig divided by Ax bar. Okay, so x bar is found out 8/3, A is known as 12.5, and x bar is known as 8/3. So the only unknown is Ig. So what is Ig? Ig is the moment of inertia of this planar surface about an axis that is passing through the center of gravity of this surface. So what is moment of inertia? You have studied in applied mechanics moment of inertia about the central axis of a triangular surface. It is bh cube divided by 36. B is the base length, h is altitude. So bh cube by 36, Ig will be 5 into 5 cube by 36. Okay, so you substitute directly here, 5 into 5 cube by 36, you will get h bar as 3.19 meters. So that is the position of the center of pressure. So in this case also you see center of gravity is 8 by 3. Okay, that comes around 2 point something from the free surface, and center of pressure is further down, it is 3.19. that is center of pressure is below the center of gravity. Okay, so what you have to know is that how to get moment of inertia of different planar shapes, and also the formula for the estimation of total pressure and center of pressure. Okay, we'll do one more problem. It is regarding a circular plate. So first we have taken in the first problem we have taken a geometry that is rectangular in nature. Second problem, it is an isosceles triangle which is held vertically. This is a circular plate which is held at an inclined position. A circular plate of 1 meter diameter, okay, is immersed in water in such a way that its plane makes an angle of 30 degrees. So inclination is the 30 degrees with the horizontal. The horizontal means with the horizontal surface of free surface of water, and the top edge is 1.25 meters below the water surface. Top edge of this circular plate. Find the total pressure on the plate and the point where it acts. That means total pressure and center of pressure. So this problem is very much similar to the first problem we had done. That is a rectangular plate which is inclined at an angle of 30 degree with the free surface of water. That was the first problem. It is very similar to that. The only thing is the geometry is different. So we'll proceed in the same way. So we skip this arrangement, sketching the arrangement part, and A is pi by 4 d square, that is 0.785 meter square, since it is a circular plate. Theta is 30. Distance of the top edge from the free surface, it is 1.25. And what is the formula for total pressure in case of inclined surface? Rho g a h bar. Okay, so it is water, and all the values are known. What is h bar? H bar is the distance of its center of gravity from the free surface. So the top edge is at a distance of 1.25. So 1.25 plus 0.5 sin 30, where 0.5 is the radius. So if you sketch that figure, you can find out h bar. In the similar way, we had found out h bar in case of a rectangular plate in the first problem. The same procedure. It is 11551 Pascal, or about 11.55 kilopascal. Then we can find out the center of pressure by this equation. H bar is 1.5. H bar is 1.5. Then Ig we have to find out. Theta is 30. A is 0.75. So here, how to get this h bar as 1.5? Because h bar is 1. You see this, h bar is 1.25 plus 0.5 sin 30. Okay, h bar is 1.25 plus 0.5 sin 30. What is 0.5 sin 30? It is 0.5 divided by 2, that is 0.25. So 1.25 plus 0.25 will give you 1.5. Okay, then how to get Ig for a circular plate? Moment of inertia about the central axis or axis passing through the center of gravity. It is pi d raised to 4 by 12. Okay, pi d raised to 4 by 12, that will give you 0.049 meter raised to 4. So h bar plus Ig sin square theta divided by A h bar, that will give you 1.51. Okay, 1.51. The center of gravity is at a distance of 1.5 meters or 150 centimeters from the free surface of water, and the center of pressure is 151 centimeters or 1.51 meters from the free surface. So again, the center of pressure is below the position of the center of gravity. So this is how we try to do some we have done some problems regarding this center of pressure and center of total pressure. So only thing we should know is the equations for total pressure and the center of pressure, and how to locate the position of the center of gravity as per the given problem. and also the equation for the moment of inertia of the given planar surface. Okay, so the question may be either vertical, plate held vertically, or plate held inclined with a particular angle. So in both the cases you can apply the corresponding formula and you can find out the total pressure and the point through which this total pressure is acting, that is center of pressure. Thank you.